Hello students, in this problem we will tackle a question from central force motion which is asked in JEST 2023. So in this problem we are given a particle of mass 1 kilogram, angular momentum L equal to root 2 kilogram meter square per second, and total energy is also given. We are given central force as well, and K is equal to 2 kilogram per second square. Now we need to find the boundaries of the particle, where the particle is bounded. So in this question, let's develop some theory related to this question. So E is equal to, total energy E is equal to 1 by 2 mv square plus V of R. This is equal to 1 by 2 m. We know that central force motion is two-dimensional because L is conserved, and to represent two-dimensional motion we use polar coordinates. So in polar coordinates we have velocity is equal to r dot r cap plus r theta dot theta cap. So V square is equal to r dot square plus r square theta dot square. So if we substitute that here, half m r dot square plus r square theta dot square plus V of R. Now we need to find what theta dot is. Theta dot is equal to, we know that angular momentum L is equal to, L vector is equal to r cross p. So in polar coordinates, r cap cross p is m into V is r dot r cap plus r theta dot theta cap. R cap cross r cap is 0, so first term will contribute nothing. From second term we have m r square theta dot r cap cross theta cap. We are only concerned about the magnitude, so magnitude of angular momentum L is equal to m r square theta dot. From here theta dot is equal to L divided by m r square. So theta dot square is equal to L square divided by m square r raised to 4. Now put this value in the equation 1. So you get E is equal to 1 by 2 m r dot square plus r square. Instead of theta dot square we substitute L square divided by m square r raised to 4 plus V of R. So total energy E is equal to 1 by 2 m r dot square plus L square divided by 2 m r square plus V of R. So this term, the given potential plus L square divided by 2 m r square, this is called V effective, effective potential. E is equal to half m r dot square plus V effective, where effective potential is equal to given potential plus L square divided by 2 m r square. So if one asks you what is the minimum value that energy can have, so E minimum is equal to V effective, that is when r dot is equal to 0, and r dot is equal to 0 at turning point. R dot is equal to 0 at turning point. R dot square can never be negative, so this term it can never be negative, so the minimum value it can have is 0, and when half m r dot square is 0, E minimum is V effective, that is the minimum value of energy. So we can write E is always greater than or equal to V effective. E can never be less than this. In our problem we are given E is equal to 3. E is equal to 3 joule, L is equal to root 2 kilogram meter square per second, K is equal to 2 kilogram per second square, and mass is 1 kilogram, and central force is F is equal to minus KR. Since everything is given in SI units, I am not concerned about units, I will just write the values. So E is equal to 3, L is equal to L is equal to root 2, M is equal to 1, K is equal to 2, and F is equal to minus KR. F is equal to minus KR means V of R is equal to KR square by 2, because V of R is equal to minus of integral F dr. So that's why V of R is equal to KR square by 2, and K is equal to 2. This implies V of R is equal to 2 into R square by 2 is equal to R square, and L square by 2 mr square, L square by 2 mr square, this is equal to root 2 square by 2 into 1 into R square. So this is equal to 1 by R square. So V effective is equal to R square, that is V of R, plus L square by 2 mr square, which is 1 by R square. So this is the V effective. So according to the formula we developed, E is greater than or equal to V effective. This implies 3 is greater than or equal to R square plus 1 by R square. Let's put R square equal to X. Then 3 is greater than or equal to R square is X. So X plus 1 by X. Now for the boundaries, at the turning points, there will be no greater than, it will be equal to. So we are concerned only about boundaries. We need to find the boundaries where the particle is constrained, where the particle is bounded. So we'll put equal sign, 3 equal to X plus 1 by X. This implies 3 equal to X square plus 1 divided by X. This implies X square minus 3X plus 1 equal to 0. So X equal to 3 plus or minus root of 9 minus 4 into 1 into 1 whole divided by 2 into 1. So this implies X equal to 3 plus or minus root 5 divided by 2. X is R square equal to X equal to 3 plus or minus root 5 divided by 2. This implies R is equal to under root 3 minus root 5 divided by 2, or R is equal to root of 3 plus root 5 divided by 2. So the correct answer will be, the particle is bounded within the annular region described by the two circles with radii r1 equal to root of 3 minus root 5 by 2 and r2 equal to root of 3 plus root 5 by 2. So the correct option is C. I hope you understood the answer. If there is any doubt, please put it in the comment section.